So hello students, welcome once again. So now today this was the question which you would have got. So on which concept is this question based? So now see, this question is based on the first principle of differentiation. Normally we use first principle of differentiation. Rather, if I have to broadly define it, I will say this question is based on the functional relation. So 1-2 question will be doing on functional relation also, because that might be really very useful and helpful in several other questions also. So now see, the question is f of x plus y. So that's a functional relation given to us. F of x plus y is equal to fx plus fy plus x plus y over xy minus 1 upon x plus y for all xy belonging to R. Of course this has to be real R except 0. Of course neither x nor y can be 0 because they are present in denominator. Okay, and we are given f dash 1. We have to find fx here. We have to find fx here. Okay, now see, where lie the hint? Where lie the hint of use of first differentiation, first principle of differentiation, or the use of maybe partial derivative? We have two approach of solving such type of questions. So as I said, I'll be uploading 1 or 2 questions more. So we'll be looking at both the approach one by one in other different type of questions. Okay, so here see, what I will suggest is I will suggest the use of partial differentiation. So use partial derivative or differentiation. Now what does that mean? That simply mean I'll be differentiating the entire given relation, which is a sort of identity because it's always true for all x and y. So entire that given relation with respect to x, treating y as a constant, and then with respect to y maybe treating x as a constant. Okay, so let's start. So if I differentiate it, okay, first of all, I will like to simplify it. So what can we simplify? Fx plus f of y plus 1 upon y plus 1 upon x minus 1 upon x plus y. Okay, now see, since I am going to use partial derivative, so this form is going to be more useful. So I will say differentiating with respect to y. So we might be required to differentiate both with respect to x and y. Let's see how we get it. Differentiating with respect to y, keeping x as a constant. Keeping x as a constant. Okay, so that's it. Now what do we get? So we get its derivative f dash of x plus y is equal to, so that's a constant, so this is gone, is equal to f dash of y minus 1 over y square, and then this is also gone, and then this is plus 1 over 1 plus x plus y whole square. Right, that's what we get. But now see, that's what I said, it may happen that we have to use both the derivatives, differentiating with respect to x, keeping y constant, with respect to y, keeping x constant. But here now if I observe that if I replace x by 1, so I think we got it. So we get f dash of 1 plus y is equal to f dash of y. Fine, and then this is minus 1 over y square, and then this is plus 1 over 1 plus y whole square. That's what we get here, isn't that? If I replace f, okay, wait. What I will do here is, rather, just a minute, instead of substituting x by y, I will like to substitute y by y, and let's keep x as 1. Okay, just a minute. So a bit of correction here. So instead of putting x by 1, I will like to put y as 1. Okay, now what will happen? So we will get f dash of 1 plus x. This is f dash of 1 minus 1 upon 1 plus 1 upon x plus 1. Right, we got it. Okay, so we got it. So what happens? So we get it as f dash of x plus 1 is equal to, this is given to be 2. So this is equal to 2 minus 1 over 1 upon x plus 1 whole square. So this is nothing but 1 plus 1 over x plus 1 whole square, and now we got it. So if I say let x plus 1 be t, So that means f dash of t is 1 plus 1 over t square. Now integrating with respect to t both the sides. So we get f of t is equal to t minus 1 by t plus some constant, and the value of that constant you can easily find out. Okay, so if you have to find that value, we we can leave it, or since we need f of x, okay, so that's fine. So x minus 1 by x plus t. Now see, if you have to find that value of c, that's what I was actually thinking. We can do it by getting the value of f of 1 if it helps. Let's try. Put x is equal to y is equal to 1 here, so we get f of 2 is equal to 2 times f of 1, and then this is plus 2 minus half. Okay. So that won't help actually, I don't think. Isn't that? Or we can then try. See, the problem is we can't put x and y anything as 0. Otherwise we could have easily found that value. So I think we can leave it as it is, but the point is the use of partial derivative to solve such question based on functional relation. In the next question I will be discussing how we can use the first principle of differentiation. We can use the first principle of differentiation here also, but here I realized while solving that we can do it easily with the help of partial differentiation, bachcho. Okay, so the use of first principle of differentiation in solving such type of question, we will look at it in the next question.